Thermodynamics is the branch of physics that deals with the relationships between heat, energy, and work. It describes how energy transfers between objects and systems, particularly through heat and work, and how this affects matter's properties and behavior. Here are some basic principles and concepts of thermodynamics. 1. Thermodynamic systems and surroundings. System, the part of the universe being studied, e.g. a gas in a cylinder. Surroundings, everything outside the system. Types of systems. Open system can exchange both matter and energy with surroundings. Closed system exchanges energy but not matter with surroundings. Isolated system does not exchange energy or matter with surroundings. Though state functions. Properties that depend only on the state of the system, not on how it got there. Examples include pressure, P, volume, V, temperature, T, and internal energy, U. 3. The zeroth law of thermodynamics. If two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This law defines temperature as a measurable and comparable property. 4. The first law of thermodynamics, law of energy conservation, states that energy cannot be created or destroyed, only transferred or converted. In thermodynamic terms, delta U Q W, where delta U is the change in internal energy of the system. Q is the heat added to the system. W is the work done by the system. 5. The second law of thermodynamics states that in any natural process, the total entropy of a system and its surroundings always increases. Entropy is a measure of disorder or randomness. This law explains the direction of heat flow, from hot to cold, and the concept of irreversibility. 6. The third law of thermodynamics states that as the temperature of a system approaches absolute zero, the entropy of a perfect crystal approaches zero. Absolute zero, 0 K, is the lowest theoretical temperature, where particles have minimal vibrational motion. 7. Enthalpy, H. A thermodynamic property that represents the total heat content of a system. It is especially useful for processes at constant pressure. The change in enthalpy, delta H, is associated with heat absorbed or released. 8. Gibbs free energy, G. A thermodynamic potential that determines the spontaneity of a process at constant temperature and pressure. The change in Gibbs free energy, delta G, tells if a process is spontaneous, delta G delta H, T delta S, where delta H is the change in enthalpy, T is the temperature, and delta S is the change in entropy. No heat and work. Heat, Q, is energy transferred due to temperature difference, while work, W, is energy transferred by force. Types of processes based on heat and work. Isothermal, constant temperature. Adiabatic, no heat exchange. Isobaric, constant pressure. Isochoric, constant.
Thermodynamic studies energy